Hi all, I'm going to explain about switched mode power supply, specifically buck converter derivation in this video. A buck converter is one in which output voltage will be less compared to the input voltage. Let us check how this happens. We have a switch here, a diode and inductor and capacitor along with the load. Now there can be two cases. One is when the switch is closed, other one is the switch is open. When the switch is closed, the diode is not forward based, freewheeling diode is not connected in the circuit as the supply passes through the switch through the inductor and through the load, and hence the inductor is charged in this and the freewheeling diode is not going to get connected and the current flows by this way. When the switch is open, obviously current flows through the inductor, through the load, through the freewheeling, and inductor is acting as a source and it is getting discharged. And this is the reason why the load is always less compared to the source. These waveforms I've already explained in the previous boost converter. Hope you'll understand. And these are the different cases. As I explained, in case 2, inductor is discharged, in case 1, inductor is getting charged. So VL on equal to Vs minus V naught by applying KVL, and when we apply KCL, we'll get the IC on. When switch is in off condition, same applying KVL and KCL, we'll obtain the VL off and IC off. When we try to get the volt second balance, we'll apply the V into time. So VL on into T on plus VL off into T off equal to 0. Substituting the VL on and VL off in these equations, at last we'll get the derivation or the equation for V naught, which is equivalent to Vs into D. So the output voltage is always less than the input voltage because it is multiplied with the duty cycle and which is between 0 to 1. And ampere second balance is again multiplying current into time. IC on into T on plus IC off into T off is equal to 0. Substituting the IC on and IC off values from the previous equations in this, we'll get IL at last equal to I naught. So average IL is equal to the load current. Next we'll get the ripple current in IL, inductor current, ripple in the inductor current. During the on period, VL on is this, we have derived already, we have obtained already, and substituting what is VL on is nothing but L into di by dt, change in current. So T on equal to dt, which is nothing but d into t we have seen in the waveform. Substituting it here, L into d del IL by del, it is dt equal to Vs into dVs. This is everything we obtained from the previous equations. At last, we'll get the expression of del IL as d into 1 minus d into Vs by F into L. So power input equal to power output. Substituting that, you'll get the source current Is, V naught into Is by IL, I naught by Vs. If we want to find IL max and IL minimum, same like the boost converter, IL max is equal to IL average plus del IL by 2. And to find the IL minimum, it is IL max my IL average minus del IL by 2. Substituting the values, we'll get it. IL average and del, it is substituted in the previous one, and so we substitute it here. Switch current is ISW, which is equal to IS. We can find the IS RMS also and ISW average and RMS by this. This waveform tells that the switch is on only for T on period, and so the waveform is this way, whereas this is the IL average. And next is when switch is off, ID average and IRMS ripple is this way because this is how you get, because the switch is off. This is the FD position, FD current, because it is not on during the switch is on. It is the current flows through the FD only when the switch is off. And with that, we'll find the ID average and ID RMS. Next is ripple voltage, ripple in the capacitor voltage or output voltage. So it is obtained del Vc or del V naught is obtained by this. We all know Q equal to CV, del Q equal to C into del Vc. Hence we know what is del Vc now. It is del Q by C. And Capacitor stores charge when the current is greater than 0. So del Vc equal to del IL by 8 into Fc. Substituting what is IL inside in that equation, we'll get the derivation by this way. Here, final one. D equal to half. Duty cycle equal to 0.5. Change in D. Vc max is equal to, at D equal to 0.5, we'll get Vc max and Ic max by this way. And this is the critical value of inductance in LC, critical value of the capacitance, CC and LC. Thank you.